In this video, we would like to present about our mini project BIO310 which titled MUC1 and HER2 positive vaccine against breast cancer. In this slide, we also present about the recommendation and the innovation ideas based on our title. The group members of this mini project are NAZIFA binti ROSMIZAM, Afini binti RAZALI, SITI NURDINI binti AZHAM, and Muhammad FIQRI ARIFF bin SAFFRI. Researchers are studying ways to use vaccines to treat cancer. This vaccine do not teach virus recognition. They get the immune system to attack the cancer cells. Some men with advanced prostate cancer are treated with personalized vaccine made from their own white blood cells. Similarly, some clinical trials are now using personalized vaccines to prevent early-stage breast cancer for returning and to treat metastatic breast cancer. Another vaccine made of HER2 proteins is also being tested. Vaccines that target hemoglobin A, which is only found on breast cancer cells and also in clinical trials. That type of vaccines now in clinical trials target is folate receptor alpha, which is found at 86% of triple-negative breast cancer cells. Many immunologists are concerned about the development of an immunotherapy approach to cancer, despite impressive progress over the last decade, such as the identification of tumor antigens and antigenic peptides as potential targets. There are still many obstacles to an effective immune response to the eradication of cancer. MUC1 and anti-MUC1 have attracted interest as potential targets for immunotherapy in the development of vaccines for cancer expressing MUC1.
MUC1 has shown tremendous potential as a novel biomarker for carcinomas. Extensive information has been obtained regarding the expression pattern of this protein in breast cancer patients. The penetrance of MUC1 upregulation in breast cancer patients is high, but the specificity and sensitivity of this protein as a molecular marker is still unclear.
Cancer vaccine is a new method to treat cancer patients. Current efforts are geared toward utilizing this knowledge to produce new breast cancer treatment targeting MUC1, including the development of anti-MUC1. Cancer vaccine help to boost the immune system in recognizing and destroy the cancer cells. This helps to generate the immune and giving a long-term immune response. Despite the encouraging preliminary result and excellent profile of tolerability, carcinoma vaccines still show limited clinical efficacy. Antigen heterogeneity and immune escape mechanism may affect the efficacy of active immunization. A potential immune effector have difficulties in assessing poorly vascularized tumor, and high tumor burden may also lead to restricting the effectiveness of vaccine.
Therefore, combining breast cancer vaccinations with other methods could be a potential way of addressing the established limitations of successful immunotherapy. However, the relationship between vaccines for breast cancer and systematic treatment might be dynamic and poorly predictable. Thus, any combinatorial strategy requires strong biologic rationale. In addition to MUC1 overexpression, advanced tumors have been shown to overexpress COX2. Celecoxib, a particular inhibitor of COX2, has been commonly used as a chemoprevention agent method for breast, colorectal, and other cancers. For example, the mice were given the MUC1 vaccine in conjunction with COX1 and COX2 inhibitors in the breast cancer mouse model. Treatment with celecoxib resulted in a decrease in tumor-associated IDO levels, which helped to improve the anti-tumor cytotoxicity of T lymphocytes. The innovation idea and entrepreneurial opportunities for MUC1 and HER2 positive vaccine against breast cancer is develop more test kits such as MUC1 solid phase sandwich ELISA, which is designed to measure the amount of the target bound between a matched antibody pair. Second, create more career opportunities in the research industry. Third, help to boost the country's economy. And lastly, commercially viable and accurate potential that generate profit for interested buyers.